In this video, we're going to look at the general equations of projectile motion. So we're going to say that t is the time of flight and r is the range of the particle, and then we can derive four useful general results. And the following equations can only use for a symmetrical path. So you can see a symmetrical path up here. This is a symmetrical path where it is symmetrical above the maximum height, I suppose we could say. Okay, first of all, horizontal motion. For the horizontal motion, this is small u I'm using, so small u is my initial speed, and it is equal to big U times cos alpha, because you can see it's gone at cos alpha. Alpha is the angle of projection with the horizontal. Your S, we're going to say is a horizontal distance, we're going to call it x, and your t, just call it t, and there is no acceleration. So that's all we've got. We'll just say no acceleration. Okay, vertically a wee bit different. Your initial velocity, so small u, is equal to big U times sine alpha. Your S, and that is put a wee upwards arrow, so that the arrow notation is always good. Your S, your displacement, is equal to y upwards, and your A, what's causing this thing to speed up or slow down, is g, and g is going down to the ground, so it's minus g upwards. And again, your t is equal to t. So now we've got our horizontal and our vertical starting points. We can then look at the vertical motion. This is for the time of flight. So we're going to look for the flight time here. This is what we're doing. Okay, so remember what you've got. Your u was equal to u, big U, sine alpha upwards. Your A is equal to minus g upwards, and your S, for you to go all the way up from the bottom up to the highest point and then back, if you think what your displacement is relative to where you started, your displacement is the same, so you haven't moved. Effectively, vertically, you haven't moved. So our displacement S is just equal to 0. And your time, I'm going to call it big T for my flight time. As I mentioned at the start of the question, flight time was capital T. So what we're going to use here is just S is equal to UT, and where I'm using lowercase, you use lowercase, and the same for uppercase. So S is equal to UT plus a half AT squared. So in this case, 0 is equal to big U sine alpha times big T. And then that's going to be minus a half times g times big T squared. So we can factorize out a capital T here, and you're going to have t upon u sine alpha minus a half g t, which means you can put either, this is this lovely thing in mathematics, this means either this first thing, you've got 0 is equal to A times B. So either A is equal to 0 or B is equal to 0. So in this case that means, so capital T is equal to 0, or that means, sorry, U sine alpha minus a half GT is equal to 0. With a wee bit of rearranging, you're going to get T is equal to capital U sine alpha divided by a half g, and if you do that out, you're going to get big T is equal to, dividing by a half, remember, is the same as multiplying by 2, so that becomes 2 big U sine alpha all divided by g. Okay, just to explain what the t equals 0 means. T equals 0, your displacement is 0, obviously at the start of the motion as well. So that's why mathematically you get two answers. You get t equals 0, so the start of time, and also at this time 2u sine alpha all over g. I would never learn this. I would never learn off that my flight time is 2u sine alpha over g, because of the type of mind I have, I would never remember it. But I would know how to do that. So I think that would be best. You'd be best placed to do the same as well. Just be able to know how to actually work that thing out. Okay, next thing we're going to look at the range. So this is going horizontally. And remember, horizontally, your speed or your velocity is constant. So distance, you're just using, very easy, distance is equal to speed times time. Now, what's not, they said our distance, we're going to call the horizontal thing a range. So r is equal to, my initial speed was, and my constant speed, I suppose in this case, is capital U cos alpha. And my time, now our time is this thing over here. So that's what we're using. So that's why it's important you do it in a certain order here. You find the flight time first, and then you find the range. So it's going to be 2 big U sine alpha all over G. Now, if you multiply that out, what you're going to get is R is equal to, and it's going to be 2 big U squared, and then you're going to have sine alpha cos alpha all divided by G. And your last line, and where this comes from, is you should remember that sine of 2 alpha is equal to 2 sine alpha cos alpha. So this 2 up here, this sine alpha and this cos alpha, that can all just be changed to sine of 2 alpha. So your R works out to be U squared times sine of 2 alpha all divided by G. And that is it. The next bit of note says the maximum horizontal range is reached when the angle is 45 degrees, and that is because the largest value that sine 2 alpha can be is 1. The largest value sine of anything can be is 1, but sine 2 alpha is 1 when 2 alpha is equal to 90 degrees, i.e. alpha is equal to 45 degrees. Okay, that might be quite sort of instinctive to you anyway, that the longest range should be when you fire something at 45 degrees, but there's really a mathematical proof. So basically, this bit here, the sine 2 alpha, the biggest that this can be is 1, and sine 2 alpha equals 1 when 2 alpha is equal to 90 degrees, so when alpha is equal to 45 degrees. So that's really a maximum proof. So the maximum range is found, and that bit just becomes 1, so it's just U squared times 1 over G. So it's just R max, maximum range then, equals U squared over G. Okay, we're going to look at our maximum height. So at maximum height, the vertical velocity is 0. So at the time when you're at the peak of a trajectory, instantaneously your vertical velocity is going to be 0. Same as if you fire a ball vertically up in the air. At the peak of the height, your speed or your velocity is going to be 0. So we're going to look at our vertical motion here to start with. So first of all, your initial velocity was capital U sine alpha. Your A was minus G. Your V, this is your final velocity, this is at maximum height, is 0. And we'll just say at max, just to put that in twice so it's really clear. And what we're trying to find is our time first of all. So we're going to use V is equal to U plus AT. So that's just going to be 0 is equal to big U sine alpha minus GT. And then we'll just say T is equal to, and it's going to be a wee bit of rearranging here. What I've done, I'm bringing the GT across the other side, so we would have really left step out, but I'll have GT is equal to U sine alpha, and then I'll divide across by the G, so that means T is equal to U sine alpha. Very unclear, apologies. U sine alpha all divided by G. Okay, if we have a look at this wee formula, what we've got is our time for to get up to the maximum height, and it was U sine alpha G. Now, if you have a look at our time for the overall motion, the whole time of flight, or flight time, I think we call it, it was 2U sine alpha over G. So if you find your maximum height time, then this can just be doubled to give you your flight time as well. So we'll just make a wee note of that in this second column here. So just say note time to max height. Can be doubled to find, I would just say, total flight time and we call it capital T. Remember, capital T is equal to 2u sine alpha over g. Okay, so why that's important is if the question had been labelled part 1 Roman numeral 1 and part 1 was to find the maximum height above the plane, and you had found this thing over here, and then part 2 had been to find the total flight time, all you need to do is answer for part 2 is multiply your part 1 by 2 instead of having to do all the stuff that we did in the earlier part of this video. Okay, so far what we've done is we've found the time to get up to the maximum height, but we haven't actually found the maximum height. So that was really just a wee bonus, wee bit extra for us there. We're now going to look at just our finding our maximum height. So your initial velocity, still going vertically, so your initial velocity is equal to big U sine alpha. Your acceleration is equal to minus g. At the maximum height, remember, it's equal to s. Your velocity is equal to s, I should say. And we're going to say that our displacement is equal to h. So h for your maximum height. Okay. So that's all that we have. So we could say that v squared equals u squared plus 2as. So we could say then that 0 is equal to big U squared sine squared alpha, and then that's going to be minus 2gh, which means 2gh is equal to u squared sine squared alpha, which means h is equal to u squared sine squared alpha, all divided by 2g. So that is your formula for your maximum height. Okay, the equations of trajectory. So the motion of the particle from O to the point P, which is xy, is considered. So you've got your horizontal motion. So we sort of set these out earlier on. U is equal to big U cos alpha. S, this is horizontally, is equal to x. Your time is equal to t, and there's no acceleration. And vertically, U is equal to big U sine alpha upwards. Your S, your vertical displacement, is equal to y. Your time is equal to t, and your acceleration is equal to minus g upwards. Okay, so for vertical motion, we're just going to use S is equal to ut plus a half at squared. I'm just going to put that in. That means y is equal to, and it's going to be big U sine alpha times t minus a half g t squared. Dot, 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 equation 1. So clearly we're going to be revisiting this very soon. For horizontal motion, we're just going to say distance. Remember, speed is constant, so distance is equal to speed times time. So in this case, x is equal to u cos alpha times time. And we're going to use this equation to find an equation or an expression for t. So t is going to be equal to x divided by big U cos alpha. Now what we're going to do with that is substitute that into equation 1. So we're just going to say sub into equation 1 and see what we're going to get. So your equation 1 is going to become, so everywhere you see t in equation 1, you're now going to replace it with x over big U cos alpha. So your u is going to be equal to big U sine alpha times my t, and I've just said my t is equal to x over big U cos alpha minus a half times your g times your t, which is big X over big U cos alpha all squared. Let's move down a wee bit so we have a bit more space. All we're going to do now is just do a wee bit of cancelling. Here you can see you've got a U and another U here, they will cancel out. You've also got a sin x and a cos x, so it's really sin x divided by, sorry, it's not x at all, it's sin alpha divided by cos alpha. Sin divided by cos, remember, gives you tan. So we can get change those two to just be tan. So far, this first bit of it just becomes, that's just going to be x times tan alpha. And over here, we've got cos, it would be cos squared on the bottom line. So 1 over cos squared is the same as sec squared. So what you really have here is minus g times x squared times sec squared alpha, I should say, sec squared alpha, and that's being divided by, I've got a 2 and I've got u squared, so it's divided by 2 big U squared. Okay, the last thing for us to do is the change, they like to have the sec squared in terms of tan. So we'll just remember a wee reminder of how we do this. Remember, sine squared of x plus cos squared of x is equal to 1. If I divide top and bottom by cos, what I will get is tan squared of x plus 1 is equal to sec squared of x. So that's how we can change our sec squared. So your last line, your y is equal to x tan alpha minus gx squared, and instead of sec squared I'll write it as 1 plus tan squared of alpha, and that was all divided by 2 u squared. Okay, so there are 4 variables in this. You've got your x, your y, your u, and your alpha. And if any 3 are known, then you can find the 4th using this equation. Not easy, but you could do it by substitution. Okay, so you've now got equations then for your range, your time of your time of flight, then your range, and then the time for the maximum height, the actual maximum height, and then also you've got your equation of trajectory, if I could speak, and that is it. Okay, again, folks, this one I would not learn off this actual formula, but I would learn how to do that. So they would ask you to prove this formula. Maybe could ask you to prove this formula in an exam. So I would learn the method of how you work through it, as opposed to learning off the final result.